Let me start from this equation here. This is forward interest parity. We know it and we love it. We think it's basically true. Okay, it's basically true. Okay, I'm going to rewrite that equation in the following way. This is just an algebraic manipulation. 1 over 1 plus f(3)(6) equals, so that's bringing that to the other side, and then bringing this 1 plus r(0)(3) all over 1 plus r(0)(6). Okay? Did I get that right? It's just algebra. Haven't changed that equation at all. What I'm going to now point out is that this is the forward rate at time 0, adding a little 0 subscript there. And I'm going to say that at time 1, there's also going to be a forward rate. Now it's 2 months ahead, because we're now at time 1, but it's starting at time 3, okay? There's going to be a forward rate, and that is going to be defined as 1 plus r, now 1(3), and 1 plus r, 1(6). There's no reason that this is the same as that. There's no reason this is the same as that. 1 over 1, you see what I'm doing now, right? In period 2, there's going to be another. If we wrote our forward contract in period 2, for 1 period ahead now, okay, it's just going to be the ratio of this 1 period interest rate and this 4 period interest rate here, okay? And it's going to, in general, be a different number than that number. And just for completeness, let's write 1 plus f(3)(6). And the interest rate from period 3 to period 3 is basically 0, okay? So really this is just 1 over 1 plus 1 plus r(3)(6). So just by manipulating the definition, what we see here is that the forward rate, okay, at maturity, at period 3, is exactly equal to the spot rate. So this thing here, where the forward rate is greater than the expected spot rate, over the lifetime of a forward contract that's written at maturity is going to be exactly equal to the spot rate. So there's a convergence sort of that happens here. Okay. This changing forward rate, okay, means, I'm just sort of, I guess, motivating it here, that this contract between the firm A and the bank, okay, changes value over its lifetime. It doesn't stay at the time that we wrote it, okay, it was a zero value transaction, right? We just swapped IOUs. I owe you for 3 months, you owe me for 6 months, and that was it. And they were equal value, and that's why no cash flow had to happen, okay? So it was a zero value transaction, okay? But from then on, it's not a zero value transaction at all, okay? One side wins and the other side loses. Okay, it's a zero-sum transaction, okay? In the sense that maybe interest rates will rise, okay, over this period, okay? In that case, one side wins. Maybe interest rates will fall over this period. In that sense, one side loses. Now, we know, because of this sort of stylized fact, that in general, okay, the bank wins. Right? Because the bank has locked in a lending rate that's greater than the expected spot rate. That's why the bank is doing this. The bank says, this looks good to me. I really doubt that I'm going to get anyone to borrow for that higher rate, come the future. So I'm going to lock this in now as a source of profits now. The firm, on the other side, says, well, I'm willing to pay a little more. I understand this thing here because I'm worried that the spot rate there's fluctuation around this expectation, and that fluctuation might be me, okay? And this thing that I'm facing is in fact a very serious survival constraint, and I want to make sure that I take care of it now, and I'm willing to pay a little premium for that. So everyone's happy, okay? Firm A and the bank are happy with this arrangement. So on average, we expect the bank to win, in that sense, okay? That if interest rates turn out as they typically are, okay, it will turn out that the firm would have been better off waiting and not locking in, but waiting for 3 months, okay? But he had peace of mind, and so he didn't lose in that sense. Okay, there's psychic gains, and possibly real economic gains from having that taken care of allows you to pay attention to other things and not worry about it. Let's have a continuous time version of this so that we can talk about it. Okay, take this item here, okay, and call this what do I call it? Forward contracts are promises to deliver goods at a future time t at a given price k. Okay, so this is the forward price. Okay, 1 over 1 plus an interest rate is a price. Okay, we recognize that. Okay, so this is kind of in price terms. Okay, and then we have, let's call this term, let's separate these out. Okay, let's call this term, okay, the spot price. Okay, because it's the price of a 6-period bond. Okay, it's a spot price, and then this is an interest rate over the next three periods. And we can write this equation in the following terms. K equals S naught E to the R T. Okay? This is just a continuous time version of that equation there, where I'm doing it in terms of prices instead of yields also. So there's two changes. That's why I did it 1 over there in anticipation of that. So doing it in prices. So this is to link up, if you've had a finance course or if you go on to have a finance course, you're going to see equations like this, okay? And I just want you to be aware that this is the same thing as that. It's a transformation of it. I'm using discrete time. I'm being more specific about the timing of cash flows because we're doing money in banking. You'll see this. This is, in the notes, will be called equation 1. Note that there's no time subscript on K here, as opposed to my time subscript there. The forward rate is established at the moment that you do the contract, and then it stays the same for 3 months, even though everything else is changing. Everything else is changing here. That means the value of the forward contract changes over time. And how does it change? The equation, the value of the forward contract, we use little f(t), okay, is the difference between the spot rate, which is changing over time, this, see this changing over time, and minus the k, just make sure that I don't miswrite this. No, this is right. K e to the minus r t minus t, okay? So what we've done is take this factor to the other side and then subtract them. So this is the things that cause the value of the forward contract to change are changes in the spot rate, which we've seen here, and changes in the term of that is left to go. That's these here, as we're discounting by less as we get closer to maturity. Okay, so now I think the intuition of that is enough. You know, this isn't a finance course. I just want you to see the factors that affect this. And now think about time. And think about the movement of this value of the forward contract over time. Check your understanding. At time 0, what's the value of the forward contract? Time 0, what's the value of the forward contract? I hear whispers, and they're right. 0. Yes, 0. Okay, and you can see that just by plugging in. If this is 0 here, okay, and that's 0 there, then these two terms are the same, and so ft is 0. Okay, the value of the so we'll start here at 0. At time 0, the value of the forward contract is 0. I said it's a swap of IOUs, right? It's a 0 value contract. Okay, that seems, I know, weird. That's why banking is hard often, because it seems like, how can anything add value that has 0 value? And it's almost always the case that we're dealing with things like that in banking. So it's a little mind-blowing. Here's another one, okay? But it's not going to be 0 typically from then on, okay? From then on, there's going to be fluctuations in the spot rate and so forth. And so let's just say that this causes like this or something like this. And then we come to time t, the maturity, okay, which is 3, okay, in our simple example here. And long side wins, okay? Okay, that's the typical case with these kinds of interest rate contracts. By the way, all of this apparatus about forwards and futures is also true for commodities and things like that have costs of storage. There's elaborate versions of this, okay? But we're really just thinking about discount bonds, because we're in the money market, okay? So we're not talking about coupons or anything. This formula gets all messed up when you add coupons. We're not talking about storage. If you're dealing with wheat, okay, you got to worry about the cost of storing wheat. And this formula will be different if you're talking about different commodities. But the basic principles are the same. The basic principles that we're talking about. I'm showing here fluctuations over the life of the forward, where sometimes the long side is ahead, sometimes the short side is ahead, but at the end the long side is ahead. But there's no cash flows until here. Okay? Here at the end, what happens? Here at the end, what happens, okay, is that there's this is st minus k, right? Because when t is a capital T, this term goes away, and so it's the spot rate at termination minus the forward rate at inception, okay? And that's how much the long side wins, okay? It's the difference between the realized spot rate and the spot rate the spot price and the spot price that you locked in, the forward price that you locked in at the beginning. But there's no cash flows. There's no cash flows until right here. In many forward contracts, what you're obliged to pay is one side gives whatever, the bushels of wheat, okay, and the other side gives the price that they locked in, So one side gives K, the price, the other side gives the bushels of wheat, okay. In financial contracts, it's typically not that, okay. It's more that one side gives the value of the bond, ST, and the other side gives K, and so they're netting. There's a cash netting, and this is what's paid from the shorts to the longs. In the event that we wind up here. If we wound up here, okay, it would go the opposite way. Their cash flow would go the opposite way.